Good day again, how are you? I hope that what did we do previously, you have recalled it, and it's okay about you. It's very important to follow us. It's very important to practice as much as you can, because these kinds of lessons that you did not discuss in the classroom, you need to work more, okay? The effort is very important in that case. Before we start, let us recall something here. We have said about the differential equation something. It's an equation between, or a relation between a variable and its subderivatives, highest order, the higher order derivatives. Now let us consider something here, the solution of a differential equation. The solution of any equation is that quantity that satisfies that equation. Now the solution of a differential equation is the function that satisfies that equation, as you know. Now observe, this is an equation E and this is the equation F. What is the difference between them? In math, we say the following. E here is in terms of y prime y and the constant 2. We call that E is satisfied by the function y. It's not derivative here, by the function y. While f, the variable here is z. So, as this equation, but we say that f is an equation which is satisfied by the function z. So, if you have, for example, that equation, let us write, for example, r prime minus 2r squared, for example, minus 3x plus 1 equal to 0. This equation is satisfied by the function r. Those are very important. They are very simple, as you will see here, because in some exercises you are going to face that problem. Now, part 2, equations, differential equations. This type talks about separable variables. What do you mean by separable variables? These equations are of the form f x dx equals f y dy. In such equations, we use the techniques of integrations. So if you are able to solve an integral, so this part is very easy to you. If you don't know, I advise you to recall what did you learn about integration and then complete this study. Techniques of integration, you know that. If we need to solve an integral, we have 3 steps. You look for a concept, which is the integration of f prime dx equals f of x. Integration of f prime of x, as you know, dx is f of x. If this doesn't work, we look for the rules that we have written previously. If the rule does not exist, we look for the techniques. Now, what are the techniques to solve an integral? You know that we have 2 different techniques in this level. One of them is the change of the variable. And the other one is the integration by parts. You know that integration by parts is the formula. If you don't know it, recall it and write it. And change of the variable, we use it whenever we have a derivative of a function multiplied by that function, and we use the techniques of the integration. Now let us complete. Example, let us solve this equation. Y dy equals x dx. How can you read this? This is a differential equation. Y dy, observe, dy and dx. To solve this, simply we are going to apply the techniques of integration. Integration of y dy is y squared over 2. Integration of x dx is x squared over 2 plus a constant k. Now, you may write it as this, or you are able to write it as y squared equals x squared plus k prime, where k prime equals 2k. That is simpler form. You are able to solve it. I think that is very nice. It's very easy. Let us take another example. If you have x dy equals y dx, how can you solve such equation? Now, x dy equals y dx. The difference between this equation and this equation, let us observe it. Here is y dy. Here is x dy. Here the variables are separated. So x and dx are written alone. Y and dy are written alone. While in this equation, no. How can we separate x alone and y alone? You use the techniques of calculations. You are able to write dy over y equals dx over x. Now we are ready to apply the integration. Now integration of dy over y, you know it's ln absolute y. Don't forget the absolute value. Integration of dx over x is ln absolute x plus a constant c. Now simply you are able to use the techniques of calculations concerning ln function and exponential function. If ln a equals b, then a equals e power b. And as you observe, then absolute y equals a, e ln absolute x plus a constant c. You know that ea plus b can be written as ea times eb. And observe, we may write absolute y, e ln absolute x is absolute x plus e power c. You know that if absolute a equals absolute b, then a equal plus or minus b. We have applied this, so y equal plus or minus x e power c. Now, plus or minus e power c is a constant. You may write it in a simpler form, which is k. This means that y equals kx. K here, it means that plus or minus e power c. We don't care about k. Observe, k is any constant. To find it, we need another information to find it as we saw previously. And k here is a constant. Simply, this is the one of equations that we are able to separate the variables. As a result, whenever we are able to separate the variables from each other, the two variables, then you are able to use the techniques of integration as we saw previously. This is a very nice idea. You may try to solve the exercises in your textbook, and if you see that equation, they are very simple to be done. Now let us move to the third kind of equations. Now, in general, we are going to see such kind of equations. And the last part, when we finish the chapter, equation of the form y prime plus ay equals to b. Now, y prime plus ay equals to b, what do you call that kind of equation? It's a first order, linear. No y squared, no y prime squared, with constant coefficients. With constant coefficients, it means that a and b are going to be constant, not variables. Now, how can we solve such equation? We are going to take an example, application 1. Let us try to solve this equation. 2y prime plus 3y equals to 0. You may take 5 minutes to think. We're not going to wait for you, but you may pause the video and complete, after 5 minutes, that video. 2y prime plus 3y equal to 0. Where is x here? How can we solve it? Let us think. What is y prime, as you remember? Yes, y prime is dy by dx. There is a remark here. It is easier. Easier, it means it's not necessary, but it is easier to divide by the coefficient of y prime to make it simpler. Then we are able to see y prime plus 3 over 2y equal to 0. And you know that y prime can be written as dy by dx plus 3 over 2y equals to 0. Now, do you know how to solve such equations? In the previous session, we have learned how to find the solution of an equation, which is differential equation, using the separable variables. Here you are able to separate the variables. How? Using the techniques of separation of the variables, dy by dx equals minus 3 over 2y. So dy over this, or over y, it depends, as you like. dy over y equals minus 3 over 2 dx. Now observe, dy over y is what? Is then absolute y. And the integration of minus 3 over 2 dx is minus 3x plus a constant c. Also completing with the techniques of calculation, we are able to write absolute y equals to e power minus 3 over 2x plus c. This is minus 3 over 2x plus c. Now we need to find y. Now pay attention to this note. The solution of that differential equation, as we said previously, is y. It's not absolute y. It's not 2y. It's not 3y. It's not y over 5. You have to find y. Okay? So use your skills in calculations to find the value of y. It's very simple. If absolute y equals that number, then y equals plus or minus e power minus 3 over 2x plus c. So this plus or minus and e power c can be written as a constant k. So as a result, y equals k e to the power minus 3 over 2x, where k is any constant. This is the first example. Let us take another example. Let us solve that equation. Now, how does this equation differ from the previous one? If you observe it, the right-hand side in that equation was 0. Here, the right-hand side is 5. Now, how to deal with that equation? Also take 5 minutes, think about it, and then complete the watching that video. As we did previously, we are going to use y prime equal dy by dx. At the end of this explanation, it's not required from you to write this proof. Okay? You are able to use the formula directly, but you have to know how to find, or how did we find that formula. It's better for you in order to be able to apply in a better way. We can write, also divide by the coefficient of y prime, get dy by dx plus 3 over 2y equals 5 over 2. Now y prime is dy by dx, and observe, plus 3 over 2y equals 5 over 2. Let us separate the variables. This is dy by dx, separated on the left-hand side. Let us write the right-hand side as minus 3 over 2y plus 5 over 2. Then, whenever you need to separate, you have many techniques. One of the best techniques is to take this one as the denominator of y. So write dy over this equals dx. And as you know, the integration of 1 over ax plus b dx is 1 over a ln absolute ax plus b. Now what is a in this case? A is minus 3 over 2. So the integration of this is 1 over this. So it's going to be minus over 3 ln minus 3 over 2y plus 5 over 2 equals what? Equals x plus a constant c. Also, we are going to use the techniques of calculations. Most probably, about 90% we have finished our study, but we need to find y as we mentioned before. Ln equals that, then absolute minus 3 over 2y plus 5 over 2 equals to e minus 3 over 2x plus a constant c prime. Also, using the properties of absolute value, absolute a equals something, then a equals plus or minus, and you know that this is a positive quantity. Minus 3 over 2y plus 5 over 2 equal that function. So minus 3 over 2y, you may read the calculations. At the end, we get y equals k e power minus 3 over 2x plus 5 over 3, where k is that constant that we have written in a simpler way. Now observe, this is the equation. We have written it as, observe please, it's better to, as we said, if it is 2y prime plus 3y equals to 5, it's better to write it as y prime plus 3 over 2y plus equals to 5 over 2. The general solution of this equation, as you observe, it's look like what? Y equal k e minus 3 over 2x plus 5 over 2. Is it 5 over 2? No, it's 5 over 3. Now, you may look at that solution. Observe, how can you deduce that solution from the equation directly without applying that proof? In general, if the equation is first order linear differential equation with constant coefficient, I'm going to insist about the constant coefficients, okay? Observe, the coefficient of y prime is 1, the coefficient of y is a, which is any constant, and b is also a constant. The general solution of that equation is given by y equals k e minus ax plus b over a, okay? Now the proof of that is written in front of you. We have followed the same technique that we have done in the previous exercise, the same. But instead of having 2 and 5 and 3, we have called them A and B, okay? You are able to read it carefully, try to match the solution with the previous one, and try to solve it by yourself, and try to prove the rule. If you are able to prove the rule, then you are able to solve the exercises concerning differential equations. Look at it carefully. It's very simple. It's very easy. Use the techniques of calculation. If you lack any information, please recall it previously. Now, as an application, if you need to solve y prime minus 5y equals 9. This is a first order linear differential equation, yes. The coefficient of y prime is 1, yes. So we are able to apply the formula directly. What is the general solution of e prime is y equal k e power 5x minus 9 over 5. The second one, 3y prime minus 2y equals to 7. Now, we have said that it's better to make the coefficient of y prime as 1. So we are able to divide by 3. Divide by 3 both sides of the equation. We get y prime minus over 3y equals 7 over 2. So applying the formula, the general solution of E is y equals k e minus ax. A here is minus over 3. So minus ax is 2 over 3x plus b over a. Observe, b is 7 over 2. A is minus over 3. Dividing these two numbers by each other, we get minus 21 over 4. At the end, 6y prime plus 7y equal to 0 also. You are able to follow the same technique. You are able to apply the same formula that we have explained previously. It's very simple. Try to apply what did we do in this session. And thank you. This is the end of the second session in differential equation. Also, we are going to complete later on. Hope that you have understood what did we do. Try to revise, try to rewind the video, and write your notes. Thank you, everybody.